Guten Abend everybody, back at it again in the Phronix channel. Today, I, Phronix, will explain to you physics, specifically force, because some people have been requesting me to do this. So first things first, force is divided into two parts. I'm basically just gonna go over the theory real quick. So there's contact and non-contact, pretty obvious from the name, quite self-explanatory. Contact force requires physical contact. This one does not require physical contact. This is a good example of contact force is like friction. An example of this is, for example, magnetic or gravitational. To explain it in simpler terms, contact force is basically like when you're holding your body pillow, basically like that. Non-contact force as when you're close with somebody but they go really far away from you and you miss them and there's a strong bond and there's just, like I said, an extremely strong feeling of you missing that person but they don't miss you back. Yes, it's sad, but we're talking about physics, completely different problem. So anyway, there's two main triangles we have to memorize. This guy and this guy. Now let me explain. This is force. Now you can put it as sigma force. No, not that kind of sigma, but sigma as in this sigma. The mathematical sigma. Nope, not that one. This. This sigma, not this one. Alright? Alright. Continue from what I said earlier. First, I will explain the first triangle. As we can see, it's a pyramid with the apex of the pyramid being F, which is force. Usually it's accompanied by the sigma. This is mass. This is acceleration. Let me explain how on earth you read this diagram. So force, because it's at the top, if we were to calculate what the force is, then what we have to do is we multiply mass with acceleration. So this multiplied by this equals this. Okay? Now how do we find the acceleration if we have the mass and we have the force? Well, it's easy. As you can see, force is at the top, m is at the bottom. I guess you can kind of read it as like a fraction. So A equals F divided by m, force divided by mass. And the same thing goes for mass. If you want to find mass, then that's force divided by acceleration. You understand? Hopefully you do. Now we're moving on. Okay, this kind of explains it a lot better. So as you can see, it's practically the same thing, except the variables are changed. Here we have mass, gravity, and weight. These two are two completely different separate things. Do not ever mix them up. Got it? It's just a matter of what we're looking for. Then yes, it depends on the triangle. So for this, it's practically the same. In order to find weight, it's mass times gravity. If you want to find the weight on a certain planet, then you have to multiply the mass of the object with the gravity of the planet or whatever. If you want to find the mass, then it's weight divided by gravity. And if you want to find the gravity, it's the weight divided by mass. Same thing. And if you still don't understand, you can take a look at this diagram. I'll pause it for like 3 seconds. You can screenshot it if you want and read it. You can pause the video if you want. Done? Alright, I'm expecting that you're done. Now, hopefully you understood the formula that goes on. Look at this. Force is ma, m is fa, a is f divided by m. Oh, sorry, m is f divided by acceleration. So ignore any weird ones there. You're gonna just move on to this. So if we ever get a question like this, we have a mass and there's a friction, and then at the bottom you want to pay attention if it says take a look at the friction or not. If it says don't pay attention to the friction, then you just calculate it as usual. So what you need to understand from this is that there's 30 newtons worth of force power pushing this little cube to the right. So there's an imaginary ghost or force pushing this cube to the right, and if you measure it, it's worth 30 newtons. Now it is given that the mass of this cube is 10 kilograms. So look at what we have. We have the force, we have the mass. Let's say we want to find the acceleration. Then the acceleration is this divided by this, which is 3 meters per second square or 3 meters per second squared to the right, since it's positive and not negative. Now, the same thing goes if we didn't have the force. If we just had the mass like this, but we have the acceleration, then we can do this, follow this thing. Mass times acceleration. So for example, ignore this. Let's just say the acceleration is 7 meters per second to 7 meters per second to the right, or 7 meters per second square. Sorry, 7 meters per square at 7 meters per second square. So that's 10 times 7. So the force would be 70 newtons. And the same thing goes for the mass. You have to divide this by the acceleration. Now, moving on to this is kind of a different one. For this, you kind of have to understand how it works. Oh, this explains it better. So as you can see, there is one force worth 6 newtons pushing into the right. But on the other hand, there's the opposite, 5.5 newtons pushing into the left. Now what will happen in this situation is the force with the greater newton will overcome the weaker one, and this will be the leading direction. However, in the event of which you get a question like this, as you can see, there's 5 newtons worth pushing into the right, and at the same time 5 newtons to the left. Now if we get C in the picture in the question, opposite forces pushing it in the opposite direction, but with equal magnitude, equal amount of newton, then you can easily just cross it off your counting list or whatever, because you don't need to count it. Because think about it this way, it's kind of like a game of tug of war. If one side pulls it to the left with a certain amount of power, but the other side pulls it to their side with the equal amount of power, then that rope or that flag in the middle of the rope is going nowhere. Kind of like when you're fighting with your friend, or fighting with your friend. Kind of like when you're fighting with your friend over a boy or a girl, the both of you pull that dude's hands, pull that woman's hands to your side, and then they pull it to their side, like a silly little game of tug of war, and at the end, there are only two consequences. Either first, that guy runs away, rejects the both of you, and the both of you completely messed up your chances in having that guy or that girl, or, worst case scenario, their limbs get torn off. That's pretty much it. Now, if you look at this, if there are forces pushing it on the right direction like this, and they didn't tell you to pay attention to the friction, then you can just easily add it. So 5 plus 5 is 10. So right now, in this specific picture, there is exactly 10 newtons worth of force pushing this rectangle to the right. Now if we look at this, how do we count this? As you can see, there's 6 newtons to the right, 4 newtons to the left. So we know that 6 newtons, because it is bigger than 4, obviously, this will be the leading direction. This will be the one to lead where the rectangle goes next, which is the right. But how many newtons exactly is it? How much is the resultant force? Well, it's 6 minus 4. Now what you need to pay attention is, if you want to count it like this, you want to do some subtraction, then it's always the positive one, or the one that goes to the right, that is subtracted to the one that goes to the left, because the left equals negative, kind of like in a, in integer line. The lefter you go, the negative it's negative, and the righter you go, it's positive. Basically like that. So it's the one to the right decreased by the value of the one going to the left. That is all.